Okay, so the question starts off and it says how to determine how many of these molecules are polar. And so we're going to have SO3, OF2, BeCl2, CCl4, and O3. So we're going to start off with the SO3, and so that's going to have 24 valence electrons because the S is going to have 6 and each O is going to have 6. And so the S is going to be in the middle because it's the least electronegative. And so we're going to have the 3 O's outside, and then we're going to put the valence electrons on the outside atoms, and then this one O, or whichever O, is going to have a double bond so that the S can have an octet. And so then the molecular geometry is going to have the S in the middle, and the O is like this. So then the bond dipoles for this is going to be from the most positive to the most negative. And so because of all the domains are the same around the central atom and all the bond dipoles cancel, just like this, because it's going to go up. This is going to go like this, and so they're going to cancel, so this is going to be non-polar. And so next we're going to have the OF2, and so the O is going to be in the middle because it's the least electronegative. And so then we're going to start and have the valence electrons on the outsides. And then put the last 2 in the middle. Oh, and OF2 is going to have 20 valence electrons. So then this is going to point like this, this is going to point like that. And so then for the molecular geometry, we're going to have the O in the middle, 2 F's like this, and there's going to be 2 non-bonding pairs. So then this is going to be bent molecular, and so these are not going to be the same domains, so they're not going to, the bond dipoles are not going to cancel, because this is going to be like this. And so this one is going to be polar. So then we have the BeCl2 next, and that's going to have 16 valence electrons. And so the Be is going to be in the middle because it's the least electronegative. And so we start on the outside. And then there are no remaining electrons. So then the bond dipole is going to go from the least to the most negative. And then the molecular geometry is going to be linear, like this. So then both of the domains are all the domains are the same around the central atom, and the bonds cancel. So then it's going to be non-polar. And so there's going to be no net molecular dipole. And then the next one is going to be the CCl4, and that one's going to have 32 valence electrons. So the C is going to be the least electronegative, so put that one in the middle, and do all the Cl's, and then do all the valence electrons. And so then the molecular geometry is going to be tetrahedral. And because of that, and all the domains are the same, and then all the bond dipoles are going to cancel. So then, like this too. So then this molecule is going to be non-polar as well. Then the last one is going to be the O3, which has 18 valence. And so connect all the O's and then do the outside ones. This is going to be a dumb one. You have this extra pair. So then when you draw the molecular geometry, the domains are not going to be the same, and so there it's going to be polar. And some common mistakes would be if you draw the Lewis structure wrong, so that, like, say there actually wasn't a non-bonding pair on the top, so then it might actually be non-polar instead.